Good evening, everyone. Posting up this video to walk us through this last example we didn't get a chance to work through in class. The sheet and the data set that we'll be working with in this example is the handout, the 2x4 ANOVA for conservatism, data set Psych 5060, 2x4 ANOVA conservatism. Again, what we're going to do here is talk about some ways we might go about correcting for multiple comparisons when we have a significant interaction, but we don't have any clear hypotheses, but want to make some corrections for multiple comparisons, particularly in a large interaction, so we're not just comparing everything at comparison-wise error rates or alpha 0.05. So with these data, what we have is, I think I made these up, but we've got ratings of conservatism, 1 to 10, with higher ratings indicating higher conservatism. Gender, 1 is male, 2 is female, and then we have religion coded. 1 is none, 2 Catholic, 3 Protestant, 4 Jewish. Okay, so what we're going to do is we're going to start by working on this data, and I'm going to go through, we'll do a quick screening just to give you another example on how we might go about this. So first thing I'm going to do is I'm going to sort by first gender and then sort by religion. Now, we already see off the bat before we get into our screening that we've got 3 values where someone didn't identify a religious affiliation, and so we're going to exclude those. We're going to cut those out of the set right away. I'm going to go up and save this as a scrap file so that I don't ruin our data. Okay, and what I would do in my screening is note the participant numbers and we would say in terms of our missing data we have 1 man and 2 women who didn't provide a religious affiliation, and so we'd note in our screening framework that we would go through and get rid of those individuals. So we'll get rid of them. Okay, but if we look down through, now we should have men and women for each one of our religious groups. Okay, and so what we can do here for the purposes of our screening, I can go through and say, all right, so this is group 1, group 2, oops, three, oops, group 4, five. This turned out to be more tedious than I'd wanted it to be. This thing is, you can fast forward through this if you like. 6. 7. And 8. Okay, what I'm going to do is I'm going to go down through now, and even though it's going to take a little bit of time to label these, it'll help us with our screening quite a bit. So this will be male, none, female, none, 3, male, Catholic, 4, five, Protestant, 6, Protestant 7, Jewish and 8. Okay, so that should get us, yep, go down, knock that down. Okay, so this will just make it easier when we go through and do our screening to go through and identify, because things will be labeled. So again, with our factorial designs, we need to have and go through and screen distributions, things along those lines within each cell. So what I'm going to do is I'm going to first go through and take a look real quick, make sure my conservatism ratings are all within bounds. It looks like they range from 5 to 10. All of those values are within range. Conservative ratings, real values 1 to 10, so we're good there. Looks like our gender was good, our religion is good, and so plausibility in terms of our screening looks pretty good, at least based on what we've got here. So what we're going to do first is we're going to go to Data, Split File. We split file by condition, organize groups by output, organize output by groups. So we're going to go through, so this will give us different output for each one of our groups, and then we can go to Analyze Descriptives. Okay, and we're going to go, want to look at conservatism. We'll save as standardized, options, request skew kurtosis, hit continue, and then we'll paste that into a syntax file. So again, if you want to label these, that's usually helpful. We'll identify this as screening. Okay, go through, take a look at our initial screening stuff. So this looks good. Everything's within plausible values. So we got 46. Skew kurtosis looks fine. All of this is looking okay. Looks like we have a little bit, our sample or our cell sizes are a little bit different, but they're all quite large. Mean standard deviations are looking all right. So nothing going on here. It looks like for our Jewish female group, looks like that's scores there a little kurtotic, but again, nothing terribly shocking based on our output here. So what we want to do now is go through and actually take a look at some of our graphs. So we're going to go to Data, Split File, turn this off, paste that. So we want to not look at this all based on condition, because then what we can do, remember, if we can go down, go to Explore, we can look at conservatism by condition. We can label cases by subject number. Statistics, no, plots. There we go. We'll request histograms here. Hit continue, and then nothing else going on here that we want. So go ahead and hit paste. And then if we go, so want to make sure we turn off that split file, otherwise we'll get a bunch of funky answers here. And just going to go through, take a look at our plots with this. So we'll go ahead and hit that. Okay, case summary, all of our good descriptive statistics, we won't worry about that. We're just interested right now in taking a look at histograms, making sure there's nothing too terribly weird going on. So again, that sort of our male participants with no religious affiliation looking pretty good. Women without a religious affiliation, sort of our Catholic men, Catholic women, Protestant men, Protestant women, Jewish men, and Jewish women. Again, nothing that looks too terribly odd or out of sorts. Our box and whisker plot, looks like our medians are fairly stable, with the exception of our women who are not affiliated with any religion. We have some values that are extending beyond 1.5 times the inner quartile range. We see subject numbers labeled right here. So it looks like we do have values that are falling outside of 1.5 times the inner quartile range, but again, looking up at our descriptives here, our histograms, it doesn't look like we have any clear outliers that we would be concerned with. We can close this out by going through and requesting once again, I want to split file by condition and paste that in. So we're going to split file by condition. We don't need to save any z values here. We know that SPSS will label our z-scores as just z conservative, and we don't need skew kurtosis for this, so we'll drop that out. And so again, just looking at our z-scores here to see if anything pops up, although based on our graphs, it doesn't look like anything should be too bad. So if we go down through, take a look for our men without a religious affiliation, nothing sort of too huge. We have high levels of, it looks like high levels of conservatism among our women without a religious affiliation. We've got at least one person scoring close to 2.5 standard deviations above the mean, but again, our graphs suggest that there's not too much going on there. Same thing with our Catholic men. Catholic women are looking pretty good. Protestant men, some high levels of conservatism, but also some low levels of conservatism as well. Again, for our Protestant women, some low levels. Our Jewish men, some low levels. Our Jewish women, about the same. So we would note maybe in our screener that we do have some values that are sort of falling along either high or low relative to the sample, but nothing based on the screening right now that would suggest that we have huge problems with assumption of normality or distribution of sample means in this stuff here. So would go through, make sure to note that, describe, give a general description of your histograms, talk about what you see going on with each one of the box and whisker plots, talk about your z-scores, things that you're finding to be high, low, and telling us what standards you're using there. But again, things are looking pretty good. Only last thing that we would want to take a look at was our homogeneity variance, but we'll get that within our ANOVA. Okay, so screening is looking all right now, and again, so the general idea with this 2x4 ANOVA is we're interested in the unique and interactive effects of gender and religion in terms of their relation with conservatism. Remember, so we're going to get 3 effects within this ANOVA model. We're going to get a main effect of gender, right? That's going to ask whether or not, in general, men have higher levels of conservatism than women, or vice versa. We're going to have a main effect of religion to see whether or not we have systematic differences in level of conservatism across people who don't identify with a religious affiliation versus Catholics versus Protestants versus sort of Jewish individuals in our sample, looking across those 4 groups. And then we're going to have an interaction. Our interaction is going to tell us whether or not we see differences in conservatism across our religious affiliation that differ across men or women. Alternatively, we could switch that around and say, do differences in conservatism across men and women depend on religious affiliation? Either one of those is looking at our interaction, right? Remember, anytime you see an interaction, the question is the relation between X and Y change based on some third variable? Okay. So that's our setup. So we can go through now and just start taking a look at our model. So we're going to go through, we're going to hit Analyze, General Linear Model, Univariate. Okay. Conservatism is going to be our dependent variable. Gender, religious affiliation are fixed factors. We're going to not going to worry about contrast, not going to worry about plots, not going to worry about post hocks. Again, you can ask for this stuff, but what it's going to do is it's going to correct for too much stuff. So we're not going to go through and take a look at that. Not going to save any values. Options. We'll get marginal means for each one of these groups. We're going to ask for descriptive statistics, estimates of effect, and our homogeneity of variance tests for this. Okay, so hit continue, and we'll hit paste, and go through here. Call this 2x4. Oops. 2x4 ANOVA. And go to run through and run it. So this is well, I think I screwed this up. Oops. No, don't want to save that. We will go through. We need to turn off our split file here. Whoops. Okay. There we go. That's what we want. Okay. So, and this is output that should be similar to what or identical to what you're getting in your handout. Again, starting at the top, we have our between subjects factors. So we have men and women, fairly, at least at this size, large samples, right? And relatively similar. Have some variability in terms of our religious affiliation. Sort of lowest number of individuals who don't identify with any religion, lower number of Jewish participants, largest number of Protestants, and then so we have some differences in terms of our religious affiliation. Here, going down for our descriptives, so these we're getting mean standard deviations and cell sizes for men who don't affiliate with a religion, men, Catholic men, Protestant men, Jewish men. Same thing for our women in our sample. And so again, we're seeing some discrepancies in our cell size. Our smallest cell are our women who don't identify with a religious affiliation. Smallest male cell is our Jewish men here, but we also don't have quite as many people who are men who didn't affiliate with a religious identification. But it looks like our means are all relatively similar. Not great news for an ANOVA design, but we'll see what happens. We also see our standard deviations fairly similar. A little bit less variability in terms of our Catholic men, but all in all, not anything that's looking like it's too crazy far out there. So we go down through, take a look at our Levine's test. So our Levine's test is saying that basically it's looking like we've got fairly similar error variance within each one of our cells. So we have a non-significant Levine's test here, suggesting that we don't have sufficient evidence to claim systematic differences in terms of the variability across our individual cells. And so this is good news. We're saying that in general, sort of the variability within each one of these cells is fairly similar, right? So this helps us out in combination with the fairly large cell sizes. Now the cell sizes aren't equal, but they're fairly large. And it looks like we won't have systematic or huge differences in terms of variability. Again, this is going to be a fairly powerful test because we've got quite a few, our cell sizes are fairly large, so I think we can confidently sort of proceed, assuming that we have relatively equal variances. If we go down through and we take a look at our ANOVA table here, we see, remember our corrected model, this is our sum of squares cells. We don't interpret that. Basically, this is our test of total effects here, so we ignore that. Our intercept, remember this is our test of our grand mean, basically tells us whether or not our grand mean for conservatism is different than 0. Again, not terribly useful for what we're doing here. And then remember, we have our sum of squares error and our mean squared error here, and then our total. We're going to not look at our total. This is sort of combining all this stuff with the intercept in there. Our corrected total is our total degrees, or sum of squares total, that we'll be interested in looking at here. So going through, taking a look, it looks like we have no evidence of a main effective gender here. Essentially, this is saying if we collapse across religious identification, really our men and our women are looking like they're reporting similar levels of conservative values. Okay, looks like we've got a marginal effect, main effective religion. Again, collapsing across gender, looks like there may be some differences in terms of overall conservatism across different religious affiliations, but again, marginal, so we might want to take a note of this, but then we see that we do have a significant interaction that's meeting our threshold here, so we got p.024. Looks like that differences in conservatism across religious identification looks to be different for men versus women. Okay, now we can interpret this either way, and we'll look at both ways. Again, we didn't come in with any hypotheses here, but it looks like I've got a marginal effect of religion and nothing going on in terms of gender. So even at this stage, what I might want to be doing is saying, well, it looks like maybe this marginal effect of religion on conservatism might be moderated by gender. Okay, but we'll look at both of those and see kind of what's going on. Here we have our partial eta squareds. Remember, we're interpreting this as the proportion of residual variability in these data that's attributable to each one of our effects. Recall that our eta squared, our partial eta squareds, are going to be inflated. So if we want to provide a population estimate, we're going to be looking at omega squared and partial omega squared, but looks like we have this interaction within these data is accounting for about 2% of the residual variability after we partial out stuff that's attributable to religion and gender. So one last thing, we might want to go down through, take a peek at our marginal means to see maybe what this interaction might look like. Again, this would be our marginal means for our main effective gender. So men and women, very similar, not much going on here. In terms of religious affiliation, again, remember this was a marginal effect. Looks like that maybe, probably what's going on are people who aren't identifying with a religious affiliation reporting slightly smaller or lower levels of conservatism than our groups who are identifying with a religion. But again, this was marginal. Here's where we found the action in these marginal means. Looking at sort of systematic differences among each one of our men for each group and women for each group. This is kind of probably where our action is going to be. And so we do see maybe not a lot of variability in men, but more variability maybe within our female participants. So, and again, if we go back up, first thing we want to do, if we have that interaction effect, we want to plot it, right? So what I'm going to do is I'm going to pull up an Excel sheet, and I'm going to put together this little graph so that I can go through and get a visual sense of what's going on here. Again, I'm going to plot in our means for our men. Okay, here we go, got those. Put in our means for our women. We got those here. Okay, so again, wanting to include those in, and then what we're going to do, highlight those, and because we're doing means-based stuff, I like to use a bar graph. Okay, so again, remember that we can plot this out a couple of different ways. What we've got here is sort of discrepancy across men and women for participants who don't identify religious affiliation, people who identify with Catholicism, Protestantism, and Judaism across gender. And so it looks like For our religious participants, men are registering slightly lower levels of conservatism than women, except for those who don't identify any religious affiliation, where we've got that switched around. But what might be useful and more efficient is to kind of flip these around. So if we highlight this, we can go up to switch rows and columns. I like this a little bit better. This looks more efficient, right? Again, what this is looking like is it looks like for men, we get similar levels of conservatism irrespective of religious affiliation. However, among women, we certainly see a big discrepancy between women who don't identify with a religious affiliation and those who do. Now, it looks like this is a pretty big discrepancy, but remember, always take a look. Remember, our conservatism scale ran from 1 to 10, and if we go through and we take a look and change this from 1 to 10, okay, now all of a sudden that doesn't look quite as big a deal. We're clearly seeing nothing going on here for our men, or nothing that at least we would anticipate. And our women, again, our women who aren't identifying with a religious affiliation, sort of lower than our other ones, but we can go down through and maybe give this a little bit. So let's call it from 5 to 9. Let's give us some perspective so we can go through and take a look and see some of the stuff that's going there. So again, here we can see clear evidence of our interaction, right? If we look at men, our individuals who aren't identifying with a religious affiliation, took a line and drew it from here to here, here to here, here to here, here to here. We're seeing lots of crosses, right? Same thing if we were to flip this around and go through and sort of draw a line across our men and across our women, we would see something a little bit different. Again, I like this in terms of outlining kind of what's going on with this interaction. You could also plot this out in a line plot, right? So this would be sort of the same data, right? But looking at the graph for women across religion versus men. Right? We could also flip this around. And so again, looking at differences across men and women across religion, we're seeing kind of positive here and negative, but we're all working with categorical and means-based stuff. I like to use these more for continuous outcomes. So, but if you just want to see, again, identify that as an interaction, this is kind of what this is looking like. Okay. So, what we want to do now is we have to identify, first what we should probably do is go through, calculate some effect sizes. So we've got partial eta squared, but remember we can calculate eta squared and omega squared and partial omega squared. If we go up and we do that, we can lay those out here. Again, eta squared, remember, is the proportion of variability in these data that's attributable to the effect. And so to calculate our eta squared, we're just going to take the sum squares for our interaction here and divide it by our total sums of squares, which gives us 0.020. Okay, so in this case, our eta squared is actually the same value as our partial eta squared, or at least rounds up to it. Again, that's probably because, remember, our eta squared is the proportion of total variability. Partial eta squared is the proportion of residual variability after we account for variability in our outcome that's due to religion and gender. But given that religion and gender really aren't accounting for much of anything, there's not much being sucked out of that denominator, and so our partial eta squared and our eta squared are pretty similar here. Same thing if we wanted to calculate omega squared. We would take our degrees of freedom times our f minus 1 in the numerator, take that over degrees of freedom times our f for all three of our effects plus our sample size, which is 246. If we go through calculate omega squared is going to be 0.014. Okay, so again, remember our eta squared is always going to be larger than our omega squared, but omega squared is, or eta squared, largely inflated. Omega squared still inflated, but not as much. This is going to be a better estimate of the total, the proportion of total variability in the population expected to be accounted for by this interaction of gender and religion. Alternatively, we can calculate partial omega squared, and this is probably going to be our best bet in terms of an omnibus effect size to be reporting for a factorial ANOVA design. Remember, our partial effect sizes, our partial coefficients, are going to be more useful in terms of comparing across different types of designs. Our partial eta squared here is 0.02. If we go through calculate our partial omega squared, again, what we would interpret this as saying, we would guess that the interaction of gender and religion would account for about 1.5% of the variability in conservatism within the general population. Okay, remember that our eta squared and our partial eta squared, these are descriptive statistics talking to the sample. Our omega and omega, partial omega statistics, these are going to be more appropriate for population effects. Okay, so we've calculated our effect size. We've gone through when we've graphed out and sort of gotten a sense for what's going on, but because we don't have an a priori hypothesis about how this was going to turn out, at least for this example, what we need to do is we need to come up with some sort of game plan on how we're going to go through and manage our error rates here. So first thing we want to do is determine how many meaningful effects are going to be found with, or we can look at within this interaction. Okay, so we've got, in this 2x4 design, we've got 8 means, right? 1, 2, 3, 4, 5, 6, 7, 8. So 8 means, right? Technically, there are going to be 28 possible comparisons that could be pairwise comparisons that could be made out of these 8 means. So remember, if we take 8 and multiply that by 8 minus 1 and divide that by 2, it's going to give us 28 possible pairwise comparisons that could be made within these means. However, remember that for our factorial designs, not all 28 of those means comparisons are going to be meaningful, right? And so what we want to do is determine how many meaningful comparisons could be made in this 2x4 interaction. So if we start here and take a look among our men, we could go compare here 1, 2, 3, 4, 5, 6. So among the men, right, there's 6 meaningful comparisons that could be made across religion. So we got 6 here. We're going to have the same 6 among our women. 1, 2, 3, 4, 5, 6, right? So that's 12. And then also we can compare men and women within each religion group. So we've got 1, 2, 3, 4, right? So we've got 6 here, and 4 across here, giving us a total of 16 meaningful comparisons that could be made in this 2x4 interaction. Okay, so what we need to do is we need to think about what's the best way to go through and try and correct for 16 possible comparisons. Now this is a lot, right? And we're going to get penalized heavily because we didn't come in with any a priori hypotheses. But essentially, by looking at the means and plotting this out, we've already gone through, whether we want to admit it or not, and made all of those 16 comparisons. And so what we need to go and do it now is go through and sort of make corrections for those. Okay, so some options, right? We're not going to go through and request omnibus, post hoc tests within SPSS, because that's going to correct for 28 comparisons. That's too much. We're not trying to correct for all 28. But what we can do is go through and start to think about some other strategies. Now, one we're not going to Bonferroni correct for 16 comparisons. Again, remember, Bonferroni Dunn-Sidek is intended to provide some protection for a small set of either exploratory or planned comparisons, but we're not wanting to probably correct for more than 3 or 4 with Bonferroni or Dunn-Sidek. Otherwise, it's going to be far too heavy of a penalty, so we're not going to do that. We're not going to request post hoc tests in SPSS because that's going to correct for all 28. That's not going to be useful. And so remember, we had this modified Tukey procedure that we talked about in the one-way ANOVA approach. What we might do is start to see what might be useful in determining a reasonable level of correction within our data. And so we can start taking a look at sort of how many comparisons would be corrected for with certain R values for our Tukey statistic, right? So if we set R equal to 4, that's going to correct for 6 tests. 4 times 3 divided by 2 is 6. So 6 tests, we have 16. That's not going to be big enough. If we set R equal to 5, that's going to correct for 10. That's still a little bit low. If we set R equal to 6, that's going to correct for 15. Again, 6 times 5 divided by 2 is 15. That's close. We've got 16 possible comparisons that could be made in this interaction. If we set R equal to 6, that would correct for 15 of them, so that's pretty close. If we jump up to 7, that's going to correct for 21. That's going to be too much, right? So I'm thinking that probably 6 is good, right? But recognizing that 6 is not going to account for all the possible comparisons we can make. So this is still a little bit liberal, but it's better than 5. 7 is too many. So I think we're going to maybe proceed with R equals 6. Okay, so we've chosen our R. Next thing we have to do before we can get a Q statistic, we need to decide how many degrees of freedom that we're going to use here. Okay, now we could use the degrees of freedom error from our overall from our overall factorial design here, and so we could set our Q degrees of freedom equal to 454, but that seems too liberal, right? That's a really high degrees of freedom, and particularly if we're not correcting for all the comparisons that we're actually going to make here, that seems like too much. Okay. We could also go through and we could decide to use the degrees of freedom for our simple effects ANOVA, right? So when we go through and we split by gender and look at differences in conservatism across religious affiliations for men and then separately for women, we could use the degrees of freedom error from that simple effects ANOVA, but again, that's going to be really large, which is going to be pretty, it's going to be too liberal, and also the degrees of freedom are going to be different for the men versus the women because we don't have a completely balanced design. So maybe I'm not too excited for that. We could also decide to set our degrees of freedom equal to the number of degrees of freedom for each pairwise test, right? So if we're going to go up and say we want to compare for men, Catholic men and Protestant men, right? We could take and set our Q value equal to the degrees of freedom for that test, and then we could look at Catholic versus Jewish and use and set a new critical value or new critical Q based on the degrees of freedom for that contrast, and then for our non-affiliated men and our Catholic men, and so we could do that, right? But what would end up happening is we'd end up with a different critical Q for each one of our tests, and that seems, again, kind of complicated. Okay, so I'm going to scratch that off my list. But what I could do, again, recognizing that I'm going to account for 15 tests if I set Q or R equal to 6. So that's going to be a little liberal. Maybe what I want to do then is go through and set the degrees of freedom for my Q statistic, for my critical statistic, at the lowest degree of freedom of all the possible comparisons that I could make. Okay, essentially what this would do, if I do this, I'm saying, okay, what's the smallest degrees of freedom of any of the pairwise tests that I could make in here, and then set that critical value equal to that lowest degrees of freedom. Okay, this is a little bit more conservative, but we're also not correcting. We're only correcting for 15 tests when there's 16 possible tests there. And so I sort of feel like this is a nice balance. So if we go through and we take a look at the comparisons that could be made, looks like my lowest or my smallest cells are for, if I were to compare for those individuals, participants not reporting a religious affiliation, if I were to compare the men and the women, that's going to be a total sample, if I'm just looking at those groups, of 76. That's going to give me 74 degrees of freedom within that specific contrast. So total sample size there minus 2 is going to give us a total degrees of freedom equal to 74. And then the degrees of freedom for any other comparison that I would make is going to be higher. So even within, so if I'm looking at unaffiliated men and Jewish men, that's still going to be a higher degrees of freedom. Among our women, our unaffiliated women and our Jewish women, again, that's going to be larger. That's going to be 78, which would give 76 degrees of freedom. And so it looks like the lowest degree of freedom, the comparison that's going to have the least number of people that I could make, is going to be my unaffiliated men and my unaffiliated women. The degrees of freedom for that specific contrast would be 74. And so that's what I'm going to decide to do and set up and use as my, to derive my Q value. Okay, so we're going to set R equal to 6, degrees of freedom equal to 74. Now, this would be difficult to find in a table, but with the power of the internet, I can just go through and I could find critical Q value calculator. Okay, pull up this here. Again, this is just Bastard seems reasonable, right? We want 0.05 and 0.01 critical values for studentized range Q. And so again, we're going to set for this, we're going to set R equal to 6, because that's going to correct for 15 comparisons. And my degrees of freedom, lowest degrees of freedom in these comparisons is going to be, again, between my unaffiliated men, unaffiliated women. Again, if we're looking at our bar graph here, it's going to be these two groups, right? This is the comparison that's going to have the least amount of people. Total degrees of freedom in that contrast of 74. So we're going to put that here and then calculate. And so with R equal to 6 and degrees of freedom equal to 74, my critical Q in this modified Tukey is going to be 4.15. Okay, and so what I can do then is I can go through and I can say, all right, my critical Q with 74 degrees of freedom, right? This is going to be my most conservative Q for that would be reasonable given the degrees of freedom I have, is equal to 4.15. Then take that critical Q value and translate it into a critical T. So take 4.15, divide it by the square root of 2, gives me a critical T of 2.934. Okay, so again, this is our new critical value adjusted for 15 comparisons at 74 degrees of freedom. Now this is going to be a little more, we're a little liberal in terms of we're not correcting for exactly 16 comparisons, but we're also being a little more conservative because we're setting our degrees of freedom equal to the lowest value that we have. Again, if we were to go up here and set this to, let's say, told it if we use the degrees of freedom error from our overall factorial ANOVA table, 454, we set that to 454 and calculate it, right? So we get a smaller Q, which is going to give us a lower critical T, which is going to be a more liberal test, right? So what we're going to do is we're going to say 46 degrees of freedom, 74 degrees of freedom, calculate. Okay, and so what we've done here is we've gone through and used this modified Tukey to go through and say, all right, every single test, every single pairwise comparison that I make, I'm going to ignore the p-value. But what I'm going to do is I'm going to go through and I'm going to look at the test statistic, and if the test statistic exceeds 2.934, then I'm going to calculate. Then I'm going to say yes, this is met criteria for statistical significance given our modified Tukey correction for multiple comparisons at alpha 0.05. If it's less than that, we're going to say, well, it didn't meet our corrected threshold. And again, we're adjusting for 15 comparisons. This is a pretty large adjustment, okay? But we're making a lot of exploratory comparisons here, and so we want to be fairly conservative with this, okay? So we've got our new corrected statistic, right? This is going to be our new p-value, or our new corrected value. So what we want to do now is start to go through and piece this interaction apart, okay? So what I'm going to do first, if I'm looking at this, what I'm going to start out with by doing is I'm going to go through and run a simple effects ANOVA for men and then for women, okay? What this is going to do with this one-way ANOVA, it's going to say, okay, based on this one-way ANOVA, are we getting reliable differences in conservatism across religious affiliation for men and across for women? This is going to get these pairwise comparisons, all right? Or tell us whether or not we should even sort of proceed with this stuff, okay? So what I'm going to do is I'm going to, oops, that's my syntax, okay? Go to data, split file, not by condition this time. We're going to split the file by gender. Okay, so what this is going to do is it's going to give us a different analysis for men and a different analysis for women. Okay, you're going to hit paste. And then what I'm going to do is I'm going to go analyze, go to compare means, one-way ANOVA. I'm going to look at conservatism by religious affiliation. Okay, I'm going to go up to my options, ask for descriptives, homogeneity variance test, and my Welch's. Continue that. Now, I could ask for post hocs, right? But what's going to happen is the post hoc test is only going to correct for 6 comparisons, right? And so we don't want to do this, because what we would be doing if we did that is then correcting for something that we already are going to be correcting for in terms of our new critical value here, right? So we're not even going to do this. We're just going to go through and run our ANOVA designs here. So I'm going to go ahead and paste. Okay, and sort of note that what we're doing here, simple effects, ANOVA for men and women. Okay. Go through, highlight, and run this. Okay, so what we've got, we've got our one-way for men. Got our means for men, standard deviations for men, confidence intervals around the means, mins, max, and things along those lines. Homogeneity of variance test for our men. It looks like we haven't violated homogeneity of variance, so we're saying that the variability of conservatism across religious affiliation in our men is fairly similar. Okay, but if we go down through and we take a look at our one-way ANOVA, not even close. Okay. Not even sort of in the vicinity of something that we might even call marginal, right? And so what I'm going to do now is I'm going to go through and say this, nothing much going on here. So I'm done with this, right? My one-way ANOVA said that there's no reliable differences, no omnibus differences in conservatism across men. So I'm going to say these guys are all pretty similar, and I'm going to leave that one alone, okay? So what that's suggesting, given that we found an interaction, is that there's probably differences going on here. Visually, we can see that it looks like at least our unaffiliated women are reporting lower levels of conservatism than maybe some of our other groups, but we can go down through and take a look. So if we go down through and we take a look at our simple effects ANOVA for our women, okay? Again, seeing higher levels of conservatism among our Catholic women and our unaffiliated women the lowest. We knew that because we have eyeballs and can see that from our graph. Also see that we don't violate homogeneity of variance here in our among our female participants. So we're saying the variability here in terms of conservatism across our women is all relatively similar. And then we go down through and we see that yes, in fact, that we do have a significant omnibus test here, suggesting that religious affiliation differs in at least, conservatism, level of conservatism differs in at least one of these religious groups. Okay, so what we're going to do now is we can go down through and we're going to proceed with pairwise tests for our women, right? But our men, these are all similar, so we're not going to fool around with that anymore. That simple effects ANOVA said there wasn't any action going on in here, and so we're going to leave that one be. Okay, so what we need to do now is look at pairwise tests here. So what we're going to do is we're going to go to our data. We're going to go to Analyze, Compare Means, Independent Sample t-test. Okay, and we're going to look at conservatism across religious affiliation. Okay, and it's going to define our groups. Now remember, our religious affiliation is coded 1, 2, 3, 4. Okay, so for this first test, we're going to compare 1 and 2. Okay, this is going to give us a test among, because we still have that split file on, right? For our women, it's going to compare unaffiliated women with our Catholic women. Okay, I'm going to hit continue, and then I'm going to paste. Okay, now if I go to my my syntax here, right? I've got this test for comparing my non-affiliated women with my Catholic women. Now, I could go through the pull-down menu and do this over and over and over again, but what's going to be easier, I know that I'm going to make 1, 2, 3, 4, 5, 6 different possible pairwise comparisons among my women, and so what I can do is I can copy this. So we got 1, 2, 3, 4, 5, 6, and then I can just go through and change this. So this is 1 and 3. So this is my unaffiliated and my Protestant women, my unaffiliated and Jewish women, Catholic, Protestant, Catholic, Jewish, and Protestant, Jewish. Okay, so what I've got here now, so move this down, is our pairwise tests for each one of our possible comparisons. Now, because I still have this split by gender, what this is going to do is it's going to give me effects tests for men and for women both, but I'm going to ignore the men because my omnibus test already said that there wasn't anything really going on there, wasn't even close, right? So what I'm going to do, remember that this is still, file is still split by gender. I'm going to go through, and what I'm going to do here is this is going to give me the test of each one of these. Okay? So, go through and run this, and this is what we've got. So, scroll back up to the top here. That's my ANOVAs. Okay, so let's expand this out. So we've got our test for men, right? None versus Catholic. But again, we're not interested in the men because our simple effects ANOVA said there wasn't anything going on there. So we're going to scroll down to our women. Looks like, based on these data, right, that we do have a reliable difference between in conservatism between Catholic women and women who did not report any religious affiliation. Okay, and we see that p-value significant at less than 0.001. But recall that what we're doing is what we need to do is we need to take a look at our modified critical value in order to determine whether or not we're going to claim statistical significance based on our correction for multiple comparisons. And so if we take a look here, we say that our test statistic is 3.67. That's larger than 2.934. And so we're going to say that, yes, we do see a statistically significant difference across Catholic and unaffiliated women in terms of conservatism, even with the correction for multiple comparisons in this sample. Okay, what I might also do here is maybe go through and calculate an effect size, right? So if we go through and we pull up your handy-dandy calculator, we say our mean for our unaffiliated women is 7.1, 8.04, standard deviation 1.185, 1.095, and then we've got 30 women in this group, 56 in that group, and this is going to give us our Hedges G of 0.83. So we've got a large effect here. Okay, we could also go through and take that test statistic, get a non-centrality parameter for our upper and lower, calculate a confidence interval around that if we wanted to. You guys know how to do that, so we won't worry about that here. Okay, but something that you could do if you were interested in differences there, or sort of what confidence interval around this large effect that we've found here. Okay, so if we're writing down, keeping track, it looks like we do have a reliable effect in terms of differences in conservatism, with our Catholic women reporting higher levels of statistically higher levels of conservatism than our unaffiliated women, even after controlling for all these comparisons in this sample, and this effect being consistent with a large effect. Essentially about 0.8 of a standard deviation greater levels of conservatism among our Catholic women than our unaffiliated women. Okay, so back to this one. All right, so we go down through, ignoring our test for our unaffiliated and Protestant men because our simple effects ANOVA wasn't significant. Going down to taking a look at our women. Looks like we do have a statistically significant difference here at alpha 0.05. Our p-value is 0.004. But if we go through and we take a look at our test statistic, okay, again, no unequal variances here. If we look at our test statistic is 2.928, which doesn't exceed our heavily corrected critical value of 2.934, and so technically we would say that we haven't reached our threshold for statistical significance based on our modified Tukey post hoc procedure there. It's very close, but it hasn't gotten there. If we wanted to go through and calculate our effect size here, again, we're looking at our unaffiliated women, that's the same. But if we go 7.84, 1.194, and 83 women here, still got a medium effect, or a medium effect here of 0.62, so about 0.6 of a standard deviation difference in terms of our effect from this group to that group, right? With our Protestant women scoring higher than our unaffiliated women. However, because we're looking at 16 different pairwise comparisons, we get a pretty heavy penalty for that. And even though this is statistically significant, 0.00 whatever it was, 0.004, technically we would say that we haven't met our threshold for statistical significance, but we would still probably note that we've got a medium effect in terms of our difference here. Okay, so go back here, go down through, again ignoring the output for men, and again our output for women. Again, looks like our Jewish female participants scoring higher levels of conservatism than our unaffiliated women. But again, our test statistic here, 2.545, does not exceed our critical value set by our modified Tukey of 2.934. And so again, you're seeing that we normally, if we were looking at per comparison error rates, we've got a statistically reliable difference here. We've incurred a steep penalty for all the possible pairwise comparisons within this interaction. Okay, so again, going through calculating our effect size here, that's 7.81 with 1.214, 48 women, and so again, an effect size of 0.59. So again, medium effect here, but again, not something that we can claim statistical significance, formal statistical significance, based on our critical value or modified Tukey for multiple comparisons. Okay, so again, to recap here, we're seeing that our unaffiliated women are scoring lower levels of conservatism than all three of our female religious groups, but only one of these, the unaffiliated and the Catholic women, have reached our threshold for statistical significance given all of our corrections here. Okay, and that would be this here. Going down through, taking a look at our other comparisons. So this is comparisons within our participants who have identified a religious affiliation, again ignoring men. Nothing going on in terms of differences in terms of our Catholic and Protestant women. Nothing going on in terms of our differences in terms of our Catholic and Jewish women. And nothing different here in terms of our Protestant and Jewish women. And so what it's looking like is our unaffiliated women are looking like they're scoring reliably different, or they're looking in general scoring lower levels of conservatism than our other religious groups here. However, this one is the only one that's meeting criteria based on our adjusted statistical test. So we're seeing medium effects here and here, but it's only this one that's hit statistical significance. So nothing going on here. Seeing some differences here, right? And so we've gone through and run comparisons within religious group for men and for women. Other thing we can do now, and we should do, is go through and test differences across men and women within each religious group. So that's what we're going to look at: unaffiliated men and women, Catholic men and women, Protestant men and women, Jewish men and women. Okay, so what we're going to do here is we're going to go through and we will go to Data, Split File. This time, instead of split file by gender, we're going to split file by religious affiliation. What this is going to do is it's going to allow us to test whether or not we see differences across men and women within each one of these religious groups. Okay, so I'm going to hit Paste. Then I'm going to Analyze, Compare Means, Independent Sample T-Test. Take conservatism is still what I want here. Okay, and now I want to look at differences in conservatism across gender. That's going to be the same. 1 men, 2 women. Conservatism. I'm going to hit Paste. Take a look at my men. Male-female comparisons by religion. Okay, we're going to go through and we're going to now sort by a religious group and comparing men and women on conservatism. Run that. All right. So getting a start here. So it looks like, again, for our men and women, our unaffiliated men and women, looks like our women are scoring slightly lower, but again, a marginal effect here. And again, nothing that our test statistic is falling far below our corrected value to claim statistical significance. So nothing going on there, or not much going on there at least. For our Catholic participants, again, looks like marginal, right? With our men or our women scoring greater levels of conservatism than men. Something marginal if at alpha or per comparison error rates, but again, nothing that's coming close to our correction for multiple comparisons. For our Protestant group, again, something similar, but again, nothing that's reaching our threshold here. And again, same thing for our Jewish men and women, nothing hitting criteria in here. So, what we've got, if we're looking at our tests here, so this, none of our male-female comparisons within each one of our, or across each one of our religious groups is registering as statistically significant. And so it looks like the only real difference that we're getting here is in terms of, at least after we've corrected for all these comparisons, is going to be just this reliable difference between our unaffiliated women and our Catholic women, with some marginal effects maybe here and here. Everything else failing to meet criteria for statistical significance, and mostly because we've conservatively corrected for 15 in an effort to account for sort of this exploratory analysis, so this exploratory decomposition of this interaction. Okay, so if we wanted to graph this out, something that looked, thought I had this up. There we go. Maybe if we were going to present this in a paper or something like that, we wouldn't use color, but maybe something that looks like this to show that within this interaction, right, we've got a reliable difference here, maybe some marginal, if we want to call these marginal differences here, but this is where our differences are occurring. Nothing much going on here among the men. Within the women, see less conservative beliefs among our unaffiliated women as compared to our Catholic women, and that effect is consistent with a large effect, about 0.8 of a standard deviation. Here we've got a medium effect, and here we've got a medium effect, both about 0.6 of a standard deviation, if I'm remembering correctly, but even these didn't reach criteria for statistical significance after correcting for all the exploratory analyses and exploratory tests within this interaction. Okay, so what we might say then is we could say that, summarizing this, and this is when it starts to become important, you can go through and you can say these are where the differences is, this is different, that's not different, things along those lines. But again, what you want to do is pull all this together to try and put together some meaningful discussion about what's really going on in these data. And so one way I might do this, if I was going about it, I might start by talking about that we have an interaction between gender and religion within our ANOVA design, suggesting that differences in conservatism across religious affiliation are dependent on gender, right? So these differences we see in terms of conservatism across different religious groups looks like it's dependent on gender, right? The pattern of differences change whether or not we're talking about men versus women. Okay, if we go through and we run a simple effects ANOVA, so we're just looking at differences in conservatism across religious groups for men and then separately for women, we see that levels of conservatism fairly similar across religious affiliation in men. At least in these data, men are looking like they're all scoring about the same level of conservatism, irrespective of whether or not what they're identifying as their religious affiliation. However, we see that religious affiliation does appear to be related to conservatism among our female participants. Okay, we see that in general, women who didn't identify religious affiliation had lower overall levels of conservatism relative to women identifying as Catholic, Protestant, or Jewish. Okay, while we see that these differences here, and again, these were these differences that we identified here, associated with moderate to large effects. Only the differences between our unaffiliated women and our Catholic women reached formal criteria for statistical significance after our correction for multiple comparisons. And again, sort of thinking about when you're running these analyses, if you're doing a nice job of correcting, have to be careful in your design about how big this interaction is going to be, and then do I have any hypotheses about what's going on or what groups should be different? Because if you don't, and you're sort of being mindful of inflated alpha rates, you should be imposing some sort of correction. As soon as we graph those, or take a look at those means, and we graph that interaction out, we've essentially already gone through and made all 16 comparisons on our brain already. Statistically, we need to go through and correct for that. Okay. We would also say that I would probably identify that Catholic, Protestant, and Jewish women in these data reported similar levels of conservatism, right? These three groups are all similar, and we also found that men and women within each religious group appeared to have comparable levels of conservatism. We didn't find anything that came close to approaching our corrected critical value here. Okay, so again, this is just a quick summary. So basically what we're saying is that the differences in religious affiliation are dependent on gender, and specifically we see the greatest evidence of differences across unaffiliated women or women who don't affiliate with any religious community as compared to Catholic women. But again, we're seeing some differences among unaffiliated women and Jewish and Protestant women as well, probably worth following up maybe in a subsequent study where we start to anticipate these effects as opposed to, and hypothesize this as opposed to having to correct for all comparisons in the universe. All right. Now in your write-up, something along those lines, also want to have a discussion of your effect sizes, interpretation of your effect sizes here, and your confidence intervals for what you identified or calculated confidence intervals around. But again, wanting to close out your interpretation with something similar to this where you're kind of bringing it all together. So it looks like religious affiliation doesn't matter in terms of or doesn't have a big impact on levels of conservatism for men, but it does for women, specifically with our unaffiliated women tending to show lower levels of conservatism as opposed to women who are affiliated with some religious group. Okay, so this is a lot. There's a lot of stuff that goes on with this. If you're going through and sort of breaking apart these interactions, so some things to think about with this. Hopefully this gives you an idea of how to go through and sort of wrangle this Tukey procedure to provide some reasonable corrections. But again, if we would have like Bonferroni corrected for everything, nothing would have been statistically reliable, right? And so wanting to go through and make sure you're coming up with a reasonable strategy for how you're doing this. This is kind of like jazz. You just have to come up, it's sort of free form. You just have to come up with some sort of strategy that you can say, these are the pros and cons, this is why my strategy is better than these other strategies, and take something from there. So hope this was helpful. Let me know if you have any questions, and good luck on this last set.